With this section of 6.1, we are going to look specifically at word problems involving everything that we have done in the past. One thing that you need to pay attention to is when we're looking at our formulas, S equals R theta, and A equals 1/2 R squared theta, that in each of these cases, theta must be in radians. So, if you read the problem that we've been given, we're given degrees, which means that we're going to have to convert degrees to radians before we can proceed with the problems as they're given. If you look at the sketch compared to the word problem, it tells us that Erie, Pennsylvania, located here, is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north. The latitude of Columbia is 34 degrees north. So we're looking for the north-south distance. It's this really small distance here between the two cities. You need to be aware of the fact that the Earth is curved. So this distance is an arc length. It's not a linear distance. What we'll do is we'll represent the arc between the two cities. And we have to recognize the fact that really what we want is this very small distance. It's labeled as 6 degrees, but that's actually not correct. We want the angle in between these two. So we're looking for 42 degrees minus 34 degrees, which means that the angle is 8 degrees. Now, of course, rule number 1 must be in radians. So we're going to take our 8 degrees times pi over 180. So I can reduce this. 2 goes into 8 4 times and into 180. 90 times, 2 goes into 4 twice, and 45 times. So our theta is 2 pi over 45. Now that I have that, I can actually use that to find the arc length. So the next phase of this problem is S equals R theta. The radius of the equator, or the radius of the Earth, is approximately 6,400 kilometers times 2 pi over 45. In a problem like this, it's not necessary to leave any answers in terms of pi because it's a word problem, and normally we don't leave word problems in terms of pi. So I would really just multiply this through on my calculator. I'd put in 6,400 times 2 times pi, all divided by 45. When I do that, I find that S is equal to 893.609 kilometers. And of course it's a word problem, so we'll write this out as a sentence. All right, taking a look at the next problem, a rope is being wound around a drum with a radius of 3.27 meters. That's shown here. How much rope are we going to wind around the drum if the drum is rotated through an angle of 132.6 degrees? So we're looking at this rotation, which also means that we're looking at an arc length. Once again, our angle is given in degrees, so our first order of business is to get that in terms, or in radians. So we've got 132.6 times pi over 180. Because my original angle measure is a decimal and this isn't something that's easily simplified, you can plug this directly into the calculator, and what you'll find is that theta is equal to 2.314 radians. From there, we'll proceed with the arc length formula. So the arc length is 0.327 times 2.314. And with this, we get an arc length of 0.757 meters. Again, being a word problem, we'll write it as a sentence. On a problem like this with gears, this is one that is an arc length problem, but most students don't recognize it as an arc length problem. So we're told that two gears are adjusted so that the smaller gear with a radius of 3.6 drives the larger one with a radius of 5.4. The smaller gear is going to rotate through 150 degrees, so we know it's going to rotate about this much around. Through how many degrees will the larger gear rotate? Well, what you need to pay attention to when it comes to these kinds of problems is we've got all these little teeth here on the gears. So however many teeth we rotate through on the small gear, we're going to rotate through that exact amount of teeth on the larger gear, which means that the two arc lengths will be the same. So what I'll need to do before anything else is convert that 150 degrees into radians. This I can reduce. 3 goes into 15 5 times, and 3 goes into 18 6 times. So we're looking at 5 pi over 6 radians. So now I take 3.6 inches times 5 pi over 6 radians. What I've put into my calculator is 3.6 times 5 divided by 6, and I got 3. What that tells me is my arc length is 3 pi, because we can't forget that pi goes with this. So now for the next step of the problem, because the arc length on this gray gear is equal to the arc length on the purple one, I can set S equal to 3 pi. I'm given the radius of 5.4, and I can find the value of theta. Again, when I plug this into my calculator, I've actually put in 3 divided by 5.4, and that's given me 0.5 repeating, which is equal to 5/9. So I can say that my theta, because that's what I'm solving for, is 5 pi over 9. The problem is, this particular example, we were given an angle in terms of degrees, so we need to take this theta and put it back in degrees to answer the question. So we'll take 5 pi over 9 times 180 over pi. Pi cancels here, 9 cancels there, and we get 100 degrees. So we can say the larger gear will rotate 100 degrees. This last problem is going to be a sector area problem. If we read it, the Ford Model A, which, if you notice, was one of the very first cars, had a single windshield wiper on the driver's side. The total arm and blade was 10 inches long, and it rotated back and forth through an angle of 95 degrees. If the blade is 7 inches long, what is the area of the region cleaned? This here is how I know this is a sector area problem. I will do my best to sketch what this looks like. Okay, I've got a 10-inch arm that's going to rotate through 95 degrees, and it's going to clean an arc here, so that's my 95 degrees. The problem is only 7 inches of it actually gets cleaned. So I'm really looking for the area of this pink region. So what I will end up doing is I will find the whole area first. I'll find this smaller area second, and then I'll subtract them. But of course, before anything else can happen, 95 degrees must be converted to radians. If you put into your calculator 95 over 180 and you hit enter, you'll get a decimal. Then you can push the button that says math, and option 1 is fraction. It'll give you a reduced fraction for a decimal if it exists. So in this case, my reduced fraction is 19 pi over 36. It will not give that fraction in terms of pi, so what I did was I reduced 95 over 180 to be 19 over 36, and then I remembered that pi had to come with it. So that's our theta. So if I look at my area formula, what I've got on my largest area is 1/2 times 10 squared times 19 pi over 36. Plugging this directly into the calculator, I get that the large area is 82.903. My next step is to take this smaller area. So remember, if the part that I've labeled in pink is 7, then that means that this smaller one is 3. So that's going to be my R. And it still rotates through the same angle, so I still use 19 pi over 36. This gives me an area of 7.461. The final step then is to subtract them. So the area that I've shaded in pink is going to be the difference between the largest area and the smallest area. And I get 75.442. And this is in square inches.